Okay, so today we're solving rational equations algebraically and graphically. You've done this before back in math in IB last year. This year, a little bit more with maybe getting a quadratic once you've eliminated the denominator, or checking for extraneous solutions, looking at those non-permissible values and seeing if that has an effect on the solutions that you get. So algebraically, biggest thing is always remember to factor everything first. If you don't factor first, you're going to end up likely having a degree, in this case, maybe a degree 4 common denominator, not the lowest, but degree 4 common denominator, and that will make it really challenging for you to solve the equation. You'd have to use synthetic division, all that kind of stuff. So best to factor first. Then you can tell that your lowest common denominator is x plus 3 times x minus 3. By both sides. So first one here, the x plus 3's divide out, so you're left with 2x times x minus 3. Then here, the x minus 3's divide out, so you're left with x times x plus 3. You can expand in your head if you want. Here, those divide out completely. So you may have skipped to this step. Up to you, how comfortable you feel. If it's adding, pretty straightforward to do that. If it's subtracting, don't forget about changing some signs. So then that's going to be 3x squared minus 3x, bring the 18 over. I'm going to divide by 3. You can factor it if you want, but since we're solving, I'm going to divide because it's not going to have an effect. And then factor that. So that's going to be x minus 3 times x minus 2. So x equals 2 or 3. But we need to look at our non-permissible values. So, or stated as restrictions. X cannot equal positive or negative 3. So this is extraneous. And so then we want to restate this. Okay. So I'll put squiggly brackets around it for the set of solutions. Then it's clear, right? So you have to check your non-permissible values with your solutions to make sure that you get the correct solution set. Graphically, so we're just going to solve it in our calculator graphically. So go back to the original. You have a choice. You can put the left side into y1 and the right side into y2. Find the x values at the points of intersection, or you can bring everything to one side. So I'll do both methods. Let's do left side and right side of the equation. Now, newer calculators, I'm going to use the fraction. It makes it a lot easier. You don't have to worry about brackets around numerators and denominators. Oops, sorry. Okay, so that's the left side. Right side is 18. I'm not going to put the factored form. Maybe I made a mistake with factoring, right? So, oops, that's not it. Oh, sorry. Sorry. Okay, and then I'm going to do a standard screen. My solution, I think it is 2, which will show up on the standard screen. So there's the left side. The red is the right side. looks like it's at -2. Let's check. Second trace intersect. Enter, enter, enter. Okay, it intersects there at x equals -2. It also looks like it might intersect at other places. When you do the left side and the right side, when there's rationals on both sides, sometimes it's going to be a little bit difficult to see if maybe there's more than one point of intersection. So you can do that. I mean, doing the algebra for it, you know that we think there's one solution, so that makes sense. But sometimes you might just be asked to solve graphically. So doing it the other method, where we put everything on one side, so I'm going to delete my y2 and put y2 equals 0. That's the equation of the x-axis. Then I'm going to go up and keep that there and bring the right side over. So that's going to be minus 18 over x squared minus 9. Now, if I graph that, I'm looking for x-intercepts. So I can see it right there really easily. That is -2. And because I graphed y equals 0, then I can use intersect on my calculator. Okay, if you didn't, let's say you just graphed y1. Then you're going to use, for that, you're going to use second trace and 0. When y is 0, what's x? Okay, and cursor to the left of where you think it is, and cursor to the right of where you think it is. Okay, so either way works. If you're asked to solve graphically on a calculator, on a test, then 4 things. First, write out your y1 and y2, if you're using both. Next thing is your window settings. So you go to window and copy that out, usually horizontally. Then you tell the reader of your test, that's me, or diploma exam, or IB exam, what you're looking for. So in this case, when I did everything on one side, I'm looking for the x-intercepts. If the first one that I did, where I had the left side and the right side separately, I was looking for the x values of the points of intersection. So one of those statements, depending on how you're doing it, and then your solutions, whatever it is. Okay? And we'll get on to the next question. Okay, so there is a new equation. There's a constant term. Rahul, can you please work, please? Questions up here. So, factor first. Okay, multiply through by your lowest common denominator. And don't forget about that 3. Sometimes, especially if it's on the right-hand side by itself, students forget about it. Okay? Everything in the brackets here, everything on the left side has to get multiplied by that degree 2 polynomial. Now that's in factored form. If you want to show the first part, when you multiply through, you can show it as x squared plus 4x minus 5, because that's what it's equal to. And then you've done part of the expanding. Then minus 2x, the x minus 1's divide out. So it's 2x minus 2x times x plus 5. And then here, all of that divides out. Okay, now expand everything. Flip like terms, and get one side equal to 0. Can't factor it, use quadratic formula. Okay, looking at that right away, I know I can't factor it. Okay, your non-permissible values or your restrictions were -5 and +1. So that's not going to, so that's not going to eliminate them from the solution set. So in this case, there should be 2 solutions. You can check on your calculator. So again, you decide, are you bringing everything to one side or are you doing left side and right side? I would, particularly if they're irrational, I'd probably get everything to one side. So I'm going to go 3 minus. Now, if you don't have a calculator that has the fraction capability, when you do something like this, you can put the 2x without brackets, but then divide. If there's more than one term, you have to put brackets.
Otherwise, it's going to do. I remember we were doing trig, and I was wondering why I was getting all these wrong answers. And it's because what it does is it reads it just because. Yeah, because theoretically, when you think about it, like 2x divided by x minus 1, 2x divided by x, and then minus 1, that's column order of operation.
Yeah.
When you do the actual fraction, that it's unspoken that there's brackets around it.
Yeah, exactly. So just got to be careful if you do have that older version.
1 minus that?
Oh, sorry. Let's divide, but it, I think it did. Also, don't put in the factored form. Maybe you factored incorrectly, right? We'll try to use the original form as much as possible. In this case, I am moving one term over, but hopefully I got the sign correct. Okay, y2 equals 0. Graph it. I haven't sort of in my head thought about what that is, but well, that's an asymptote, right? 1, 2, 3, 4, 5. It just doesn't know what to do, right?
What about?
So.
But what about? Okay.
At -5 and 1.
Weird.
So we are going to take a look. It's going to actually, I shouldn't say it's an asymptote, but actually stop. You have to check it how far it goes past there. That should be an intercept, and that would be the other one. Your calculator won't give you radical form. So one way of doing it, you can go into trace, put -1 plus √17, close the bracket, and notice where it goes. It goes to where you think there's an intercept. It's not 0, but it's 2.7 times 10 to the -14, which is essentially 0 on the calculator, okay? Or what you can do is, let's just cursor off, say you didn't do that, and I go second trace intersect, enter, enter, enter. Copy that X value out into your calculate screen. Then take -1 plus √17 and compare those.
How did you do that?
Copy the X out.
Yeah.
You just, in your calculate screen, enter X, enter, and it copies out the X value that you were last on your graph.
There's so much. I was typing out the values of this.
I'm sure you got that already. Okay. So that one's good. Then back to trace. This one will be interesting. So let's go to -5. It's going to be undefined. I'm just going to cursor. Okay, so let's see what it gives me when I try to do intersect there. Yeah, it goes to it. Okay, so there's your X value, Y value 0. So you know that's an X intercept. Quit out of that. Now when you enter X, it'll give you that value. And that would be -1 minus √17. Okay, and you can tell it's the same. Okay, so that's how you can check. All right. And the last one for today. And I don't know. Let's hear this. Negative, sorry? Yeah?
-1 minus radical.
So those were the same.
Okay.
Pretty basic factoring in this one. Notice how if you didn't factor, you would have a quartet. 84, lowest common denominator, so please factor. 0 itself. It's amazing what we see on tests sometimes.
Really? Like they just
Well,
I mean, you can do that.
yeah,
if
but
you
think
hate
how
yourself.
complicated, yeah. Very challenging.
It's not that bad.
denominators, do any of the factors divide out within that particular fraction? What time they might, right? In this case, they don't. Okay, so now you can see that your lowest common denominator is 2 times x minus 3 times x minus 4.
Actually, I just, at this point, like, no. You can do like 2.
You can group them if you want.
Yeah, because I just like for the 1, I converted that to 2 over 2 times x minus 3, and I moved that and went the other way.
Yeah, you can rearrange and group the common denominators together and simplify those.
That's now. Sorry, that was really weird.
It's like
No, he's right. He's totally right.
total offense.
No offense.
That's so
Okay, so that'll divide out x minus 4 times x plus 1 minus x minus 4 is divide out. So 2 times x minus 3 times x plus 1 times 3 is divide out. So there is a lot of subtracting here, so make sure your signs are correct.
Okay, what are you doing? Why is the x squared so wrong?
Oh, I've got x squared minus 2x squared is negative x squared plus 3x squared is 2x squared.
Oh, why is it so wrong? Oh, wait. Oh, wait, I got the same answers. Wait, what? So if you do it my way, you don't even come across the extraneous sound. Because these two cancel out. Exists negative x, or it's negative x plus 1 becomes negative 1 over 2. So if you're looking for all answers, because I didn't come across the extraneous sound. So does it matter if since we come across it, make sure that like Yeah. Okay, so I don't have to worry about like. Okay.
Okay, so yeah, if you had grouped these terms together and found the common denominator of 2 times x minus 3, these terms together found a common denominator of 2 times x minus 4, it does work out, if you simplify those fractions, works out that the x minus 4s would divide out. So you wouldn't end up seeing an extraneous solution. Your answer would be x equals 2. You still have to state your restrictions, but as long as you show your work like that, that's good. Okay. If you do it this way, then your restriction of x can't be 4 ends up being one of these solutions here. Basically because you multiply through, in this case, I multiplied through by a quadratic. So that's introduced another solution. In your case, you multiplied through, still by a quadratic, right? No, you didn't have to because it's simplified. So you multiplied through by a linear and didn't introduce any more solution. Okay? That's it. Okay?
I was like, oh, I did something wrong, and I was like, oh no, I'm good.
I'll leave the graphing up to you. You want to check that? But that's it.